Hi everyone, we need to move on to a new chunk, and what we specifically need to look at is what do we do when exponents won't allow us to get down to a single variable. So we looked at if we start with only one appearance of our variable, what do we do? And then we looked at if we have our variable showing up more than once, but we can get it all on one side and combine down to get one variable. And now we need to look at what we do when we have, as you see in this example, an x squared and an x floating around in different terms. They're not like terms, so we can't combine them. You can do things like factor out an x, and you still have two x's, and there's no way to get down to one. Sometimes people will try, so I don't like that, getting that x squared by itself and then square rooting. This doesn't help us because we still have an x over here, right? There's still two x's. So we have to basically come up with some new tricks, and there are 3 of them that we'll use. So this first chunk is just factoring will be our trick. So I showed you factoring that doesn't work, but I will also show you factoring that does work. So I'm actually going to backpedal and give you the key to solving this problem first, and then we'll jump into some. So there's this fact about numbers called the zero product property. And I don't care if you remember what it's called. I promise I'll never quiz you on the name of it. But I want you to be really clear on what it says. It says if you multiply 2 things together and you get 0, so if, then A equals 0 or B equals 0, and that would be a mathematical or. It could be just A is 0, it could be just B is 0, or it could be both are 0. So really what this is saying in kind of a fancy way is pretty simple. The only way to multiply 2 numbers together and get 0 is if at least one of them is 0. There's no other combination of numbers that you multiply and get 0 unless one of them is 0. What I want to be really clear about is this doesn't hold. So let's say, what about A times B equals 1, or it could be 5 or 7 or whatever. We don't know anything. So just for example, we could have 1/4 times 4. We could have 1 times 1. We could have 2 times 1/2. We could have -30 times -1/30. So, I mean, I guess we know something. We know that the numbers are reciprocals, but we absolutely cannot draw any conclusions about what A is or what B is. So this property is very, very specific to 0. So basically what we're going to do is we're going to say, okay, well, if we can factor, if we can set this equal to 0 and factor, then we can claim that the solutions happen if either one of the factors is 0. And the reason this is helpful is because it allows us to break one messy equation up into 2 simpler equations where we can get down to a single variable. Okay, so let's jump into it. My examples. So I started off with one that's actually already set up for the zero product property. This is a product, right? I'm multiplying x by x minus 3 and I'm getting 0. The only way that could possibly happen is if either factor 1 x or factor 2 x minus 3 are 0. So this is going to allow us to take this messy quadratic equation. It's quadratic because it has a second power in it, and that's the highest power. So we're going to take that first factor and set it equal to 0. And we're going to take that second factor and set it equal to 0. So the original statement is true if either of these simpler statements are true. The first one's really done, right? We don't have to do anything. If x is 0, then you'll have 0 times -3, and that is 0, done. The other one is really simple to solve, and generally they are pretty darn simple, maybe 2-step equations. We can add 3 to both sides and say, okay, if x equals 3, then we get 3 times 0, which is 0. So those are our solutions. X is equal to 0 or 3. Quadratic equations don't have extraneous solutions. Factoring, splitting it up into two equations, none of those steps are going to introduce an extra solution that's not valid. So if you're checking your answers, what you should find is either they check, which means you did it right, or they don't check, which doesn't mean it's extraneous. It means you made a mistake either in your solving or your checking. So try to be clear. I know that gets confusing as we go, but there's no step happening here that would introduce an extra solution. It is possible for a quadratic equation to have no solutions, but that just means you won't find one. You'll get started and you'll get stuck somewhere along the way. So we'll see that in later sections. You don't really see that with factorable. If it's factorable, it's going to have solutions. It can have only one solution. Okay, so let's try another one. That one was really nice because it was already equal to 0 and it was already factored. My big warning before I move on is this first one, this lonely x, people like to just forget about those. For one thing, people forget to try and factor out a greatest common factor, so they won't get it factored that way. But even when they get it factored that way, they want to just pay attention to the x minus 3 equals 0 and forget about the x. So don't forget about the lonely x's.